idea to use for your u?
5x.
5x, great. So what is du? 5 dx. What value am I missing here? I need a 5. And if I put a 5 there, don't I also have to divide by 5 at the same time? Now, doesn't this equal what I need it to? So that's going to be my du, but don't I still have this 1/5? So now I'm going to integrate 1/5 cosine of 5x times 5 dx. So at this point, you can do your u substitutions. This becomes the integral of 1/5 cosine of u du. And the integral of cosine is sine. So this would be 1/5 sine of u plus c. So that'd be 1/5 sine of 5x plus c.
So whenever you're just plugging in, whenever you're just plugging in numbers, like your 5 and 5, you're taking what you need from the top to agree with the du and
Yes.
leaving anything else.
Exactly, Aaron. So Aaron just summarized for us what we're trying to do. We're trying to force this number in the top is going to make it match my du, and then you're leaving what was left over in it.
You confused me the first time because you had like something to the 1/2, and then you had like 2/2. And when you did that 1/2, I thought you were doing the chain rule or something.
Yeah.
But you were actually just leaving the 2 on the bottom.
You're putting in these coefficients. This one stays in your integrand, but that one substitutes out.
Would just dividing by du work?
Not like in this last one. Because of that x value, right?
It's okay. You have like 3 minutes.
3 minutes.
Yeah, it's almost 10:25.
Okay.
Oh, yeah, because, you didn't need the
We got
X
time.
integration.
Okay. All right. So let's just work through this one real quickly if we can.
So when you find it, you just plug in those two values.
Okay. Are these supposed to be plugged in for x, or are these supposed to be plugged in for u?
X.
These are my x values. So we can work through this problem, find the u, change it back over to x's, and then plug in those values. But there is also a shorter way. What is my du? 2
dx.
dx. Okay, so I'm missing a
2.
2.
So that's 1/2.
So that will leave a 1/2 in it, correct?
1/2.
So now it's from 0 to 4, 1/2 square root of 2x plus 1 dx. Now, I want to change these over to u's. Could I change this over to a u? This would give us 2 times 4 is 8, plus 1 would be 9. This would give us 2 times 0 is 0, plus 1 would be 1. And now, you've changed your integration limits over to u's, so you don't have to change it back over to x's. All right? Okay.
That makes sense.
He's already.
Now you can just take the antiderivative.
Now you can just take the antiderivative and leave it in terms of u,
And you still get the same.
because we've changed these limits, these integration limits, over to u's. Now isn't everything in terms of u? Yes, sir.
And that's in the second step. Would it be 2 dx there?
Oh, thank you.
And then
Yes, sir.
change it.
Thank you, Wyatt. Yes, that has to be there. Thank you. So then this would be u to the 3/2 times 2/3. What's that give me there? 9 and 1. And then evaluate it from there. And you should be able to get 26/3. If you'll stop my video there, please. Hopefully you can get 26/3 there. All right, let's make sure that you've got it.